Good evening, everyone. I'm Revannth. I'm the founder and director of Carbon Performance Limited, and I think it's nearly the end of the conference today. Before we start, I just want to thank Al, Martin, and the entire team of Develop3D Live for organizing such an amazing event and inviting me over here to speak. It's an honor being on this platform. So we've got the next 20 odd minutes. What I'm going to do is I'm going to give a small brief introduction to what carbon performance is and what exactly is it that we do. Because I think the name can be quite deceiving. A lot of people do think we work with composites, but that's not really the case. And I'll go over how we sort of incorporate different technologies like additive manufacturing, augmented reality, Internet of Things, and blockchain as well into our portfolio. And the best part is how we sort of combine these individual technologies to form an ecosystem. We call it cyber-physical ecosystem that benefits us, the end consumers, and also the environment as well. So if I ask you wonderful people in the audience, what comes to your mind when I say disruptive technologies? I think most of it would have some common answers like artificial intelligence, machine learning, big data, cloud computing, and of course additive manufacturing as well. I think that's really why we're here. But let's dial it back a bit and go back to when humans were actually just cavemen living in caves. So what was the first set of disruptive technologies? Learning how to tame wild animals and using fire proved an invaluable technological advance in human development. Fires, stones, wheels, and all these technologies were actually founded to solve some sort of an evolutionary problem. But the sad state of technology in 2019 is that they're being approached from a blue sky mindset. So if you see the graph here, the advancements in technologies are actually growing really rapidly, sort of like a 45-degree angle. But the rate of consumer adoption has always been really slow, almost flat. I mean, don't get me wrong, it always takes time for technologies to mature and also to reach the plateau of productivity. But I think in most cases, in technologies in 2019 are sort of just living on its hype and not really fulfilling the purpose of why they're there. So by definition, technology is like practical application of knowledge in a certain area. So I'm going to highlight the word practical here because I think that's really what's missing today. And of course, we all know the buzzword industrial revolution. We've all heard of it. But we've been through 3 of them. But why is the 4th one so special and literally slightly controversial as well? I think that's partly because we've overpromised what can be done and what can't, and left with the what can't be done part. And of course, we've managed to hype it up to a point where it's sort of come to a breaking point right now. So, and of course, like, you know, I grew up with 3D printing. So I was actually 11 years old when I got my very first 3D printer. It was actually from China, a couple of £100. And I've seen the industry grow from plastic to resins to metals. And of course, we've had some tremendous improvements in software capabilities and like thousands of 3D printer manufacturers. We've had softwares and also like consultancies and bureaus. But I think one question that's always been bothering me is, can we actually bring real-world practical applications to the market in volumes? And of course, aerospace industry and the medical industry has always been ahead of us. You know, they've always sort of went from prototyping to low-volume, high-value model as well. But the automotive industry, which is notorious for its carbon emissions and also for its prohibitively high volumes and very tight operational margins, has also been really wary about adopting 3D printing in them. I mean, really can't blame them. In fact, a recent Forbes study found, you know, it takes 4 to 5 years for large companies to adopt 3D printing as a core technology. So that's where Carbon Performance fit in. So Carbon Performance is an automotive consumer technology company. We develop next generation smart, connected, 3D printed, environmentally sustainable automotive components that cumulatively improve performance and fuel efficiency. See, on the surface, yes, we are a consumer brand. We do sell parts for consumers. But in the background, we are a very deep tech company. We have literally almost all possible technologies you can possibly imagine in 2019 under our portfolio, like artificial intelligence, additive manufacturing, augmented reality, Internet of Things, and blockchain. So our additive manufacturing journey has been nothing short of a roller coaster ride combined with a horror movie. Like, it's when we got into additive manufacturing, I think we were sort of in a la-la land. We were in a musical. You know, you can actually 3D print anything and everything you want. And I think a lot of people actually told us, so imagine what if you can 3D print that part of a car, imagine what if you could 3D print this part of a car. I think over the course of time, we actually got tired of imagining and we started doing. And of course, it's not really that simple. So we started our journey with motorcycle brake levers. It's a really simple part, it's a small part. We designed the motorcycle brake levers for mass production in additive manufacturing. And the result was a 60% lighter lever and designed using a combination of generator design and lattice optimization. It's cost effective as well. And then now with all the confidence and mojo that one could possibly imagine, we then stepped up our game and we went to something mostly unknown and really critical part of a car, suspension uprights. So we managed to reduce the part of the upright by 30% and improve its camber stiffness by 20%. And of course, we combined 9 parts into a single one. But the best part actually came in later on. We were actually the first company in the world to incorporate AR, IoT, and blockchain into an automotive hardware. So we call it a digital ecosystem. So in this excruciatingly painful journey, what we will actually learn is, of course, we learned a lot of technical stuff, but I think that one of the most valuable information we learned was actually from end consumers themselves. So our primary focus is actually motorsports, electric and solar cars, and also the automotive OEMs and tier ones. But we never actually expected consumers to show interest in buying our products. So we literally had to overhaul our entire business model overnight to fit into a consumer brand portfolio. So over the course of the next 2 months, once we launched the Upright, we got featured in almost all industry magazines, and every now and then we got emails from our consumers telling us how awesome we are. It's all quite flattering, but it's quite scary as well at the same time, because now you've got a community rallying for your success, and also for the industry success as well. And so you have a demand, and we think the technology is actually mature enough to fulfill this demand, and it would be an absolute injustice not to serve them. So we are challenging the status quo in the auto industry, and I'm sort of taken a giant leap of faith in metal additive manufacturing, and I've taken AM into mass production. And I'm incredibly proud to reveal what we've been working on for quite a while now. The world's first production 3D printed brake calipers. Of course, you've all seen Bugatti before, but this is the world's first production one. And what you're seeing right here is actually our motorsport brake calipers. We also have brake calipers for street applications and also for electric and solar cars as well. So these brake calipers are 15% lighter than the lightest calipers in the market. And this is not an oversell, but an engineering truth. I can vouch for it. You can check it online. So that's the one thing. And the best part is the calipers are actually smarter and also live engineered. So I'm going to come back to what smarter and live engineered means in the following slides. So yeah, just a peek at our fancy packaging. I think it wouldn't be fair if I didn't mention the support we got from our wonderful partners, many of whom are in the audience themselves. And we couldn't be really grateful for the support we've received. So yes, our core business is additive manufacturing, but we then went on a quest to find out how other Industry 4.0 technologies could actually benefit our business model and also complement 3D printed auto parts. So the first technology was augmented reality. So this technology is a beautiful piece of technology that's being undermined on so many different levels. So I'm not going to bore you with what AR means. I think most of us in the audience would know it. But I'm going to amuse you with what we actually do with AR. So a bit of a backstory here. So I was a motorsport racer for 6 years, and I'm a petrolhead by birth. And so even in 2019, if you need to buy auto parts, you still need to face a very boring and very stressful buying experience using like catalogs and brochures and confusing part numbers. So oftentimes you actually end up with like mixed parts, and you end up with wrong parts. And so we took it upon ourselves to sort of redefine the way how consumers purchase auto parts online. So we developed an augmented reality app that lets people have a try before you buy buying experience. So just like how you walk into Zara or H&M and you try on a t-shirt before you buy them. And that's exactly what we do with the app. So consumers can actually try on auto parts virtually on their cars using just their smartphones before buying them. So imagine scanning a real-life car and sort of just playing around with different parts like alloy wheels, brake calipers, uprights, and choosing the fitment and the aesthetics of it. And with one tap of a button, you can actually buy the part itself rather than having to browse through endless part numbers and chassis numbers. And it's not just about better buying experience, it's also about predictive maintenance as well. So augmented reality has opened us a platform for us to sort of understand how the part behaves in real time. So we have 100% access to the behavior of the part. And it's also opened up like a platform for our engineers to chat with the 3D printed part. It's sort of like instant chatting between a human and a 3D printed part. So they can actually communicate and interact with various engineering elements like settings and thermal settings and et cetera, et cetera. And the next one, of course, is Internet of Things. I've been meeting a lot of people this morning as well. When I say Internet of Things, I think it really scares them. It's one of those technologies it's quite really simple, but a lot of people are scared to talk about it because it's got a lot of technical jargon behind it. So it's nothing but a mutual communication between two entities, usually between a hardware and software, but it's not always the case. And the best part is it's got no human intervention whatsoever at all. So I think most of us here in the audience would be engineers, I guess. So I think finding the sweet spot between over-engineering and under-engineering with a considerable factor of safety is always quite a challenge when you're designing a structural load-bearing component. So we have a fancy name for it. Of course, we have generator design and other optimization techniques, but they are only as effective as the load conditions applied to them. So would it make sense for us to generatively design a part that's been designed with over-engineered load conditions? Absolutely not. It takes away the entire concept of efficiency from the equation. So we call it live engineering. So what we do is, so every single night, while we sleep, every single night, our parts actually get smarter, better performing, and more efficient. So our components have real-time embedded sensors in them. So real-life data is actually acquired at a very massive scale, and it's actually fed back into our loop of software and app. And our proprietary mathematical algorithm generates a data set and a digital twin, which then further optimizes the iteration. So having a good night's sleep at home, when I come back to the office in the morning, we'll say, let's have 0.005% more efficient part than the previous iteration. So over the course of time, we will actually have the lightest, but the strongest part ever. So let's take the brake calipers as an example. So existing conventional brake calipers are over-engineered purposely to fit into maximum number of cars and also to achieve economies of scales. I think that's one of the important things for automotive industry is economies of scales. What it does is it actually constrains the true potential of a car. But what we've done is we've actually taken real-life data to sort of engineer the brake calipers. So every time an iteration is sort of released, it will be better performing than the previous iteration. So of course, just like the human body, these sensors actually act as a nervous system for our components. So we can actually monitor the health of a part in real time. So saving money for our consumers and also potentially their lives as well. So of course, now we have a part that's actually lighter, stronger, better performing, efficient, and also smarter. So what this leads to is we can actually have a safer, cleaner, and greener driving as well. So when you think of counterfeit products, we usually think about fake luxury handbags and fake Rolexes and fake shoes. We don't really think about fake auto parts. I'm going to give you a few examples. Here are examples of large automotive brands sort of giving out customer warnings, notifying them and warning them not to buy certain types of products. So they are lookalike products. I'm going to highlight the word lookalike here because you can't really expect end consumers to distinguish between two parts that look the same and feel the same. So I'm going to put the problem in numbers for you so you can actually see how profound and how massive this problem actually is. So counterfeit parts are the 7th largest source of death in road accidents, and every single year, automotive companies lose £28 billion due to this problem. So how we tackle this issue is we use blockchain technology. So again, blockchain is one of those technologies that actually is quite simple, but I'm not really sure why it scares a lot of people. So blockchain and Bitcoin are two different things. So blockchain is the backbone technology, while Bitcoin is an application, just like how email is an application of the internet. So Bitcoin might fail, but blockchain is here to stay. So blockchain is nothing, but it's the name of blockchain. So it's a chain of blocks. So each block has some information stored on them. And each block has a hash. It's a unique address for the block. And each block is actually stamped with the address of the previous block. So what you have here is a chain of different blocks. So let's say if someone actually tries to tamper with the data, and of course the data stored on blockchain is immutable, which means it can't be copied, manipulated, or tampered with in real time. So let's say if I try to tamper with the data on blockchain. Oh, in fact, we actually store our step files and STL files in blockchain as well, which I think we are the only ones doing it. So if someone actually tries to tamper with the data, the address of the block is actually changed, so the entire chain actually gets broken. So we use blockchain technology to sort of give the entire journey, history, and the story of a part to our consumers. So here is an example using our very own brake calipers. So one of the issues we faced was standardization, which we've discussed with some of the members here in the audience as well in this morning, and also trust between manufacturers as well. So what blockchain does here is actually gives the entire history, right from raw materials to inception to production to post-processing to distribution to supply to logistics to and consumption and also scrapping as well. So it gives the entire lifetime of a part in the hands of consumer. So this way you can ensure 100% transparency and also have traceability to where the parts actually came from. So why we're using blockchain is it's quite simple. So consumers can actually identify whether a particular part is actually counterfeit or original, saving them money and potentially their lives. So of course, one of the most interesting parts of blockchain is something called smart contracts. So for example, let's say there are two persons, Bob and Alice, and Bob has a car he wants to sell, and Alice wants to buy this car off Bob. So usually in a traditional contract system, you usually have a third party that oversees this transaction, right? So you usually have like a bank or a car dealer, or let's say a car showroom that usually oversees and verifies this transaction. But a smart contract, on the other hand, is sort of like a self-executing computer code that's stored on the blockchain. So if certain conditions are met, the code actually self-executes itself, and everyone on the blockchain can verify this transaction, and you can actually trace the transaction back to its source. For example, in this case, let's say Bob and Alice agree on having £20,000 sent to Bob's account to transfer the ownership of the car. So we can have a smart code on the blockchain, and if this condition is met, the transfership of the car is actually transmitted over the blockchain. and no third person actually can claim that they own the car, and that's the brilliant part of it, security. So of course, oftentimes people actually ask us, what's the big deal with auto parts? Like, when the world is actually moving towards electric and solar cars and connected cars, what's the big deal? Who cares, right? But on a primitive level, a car is just a bunch of automotive parts put together, right? So even today, automakers are actually finding ways and means to improve engine performance and also reduce the vehicle weight by trying to make the 30,000 parts of a car lighter. So we have a very large playing field. So be it electric, petrol, diesel, solar, connected, autonomous, self-driving, whatever it is, a car will still have automotive parts in them. So through our sustainable innovations, this year we'll actually save 80,000 liters of fuel and also 190 tons of carbon dioxide emissions. So to put things in perspective, for every 300 cars on our roads, we will actually go on and remove one car off our road in terms of its environmental damage. So I'm going to come to the previous slide right now. So of course, we've been talking about a lot of disruptive technologies and individual technologies for quite a while now. But how do these technologies sort of interact with each other? Right. So what we've done is we've built a cyber-physical ecosystem using these individual technologies such as artificial intelligence, additive manufacturing, augmented reality, Internet of Things, and also blockchain to form a cyber-physical ecosystem that actually connects the physical world with the digital world. So we let these individual technologies sort of interact and communicate with each other automatically and in real time. So you can actually see the flow of data here. So what happens is it lets us automate certain parts of a product development, manufacturing, and maintenance. So it saves us money and also time as well. So yeah, I've been meeting some wonderful people in the audience before the speech. So if you're interested in knowing more, please do come and say hi. I'll be in the audience for the next talk. And we are based in Leeds, so if you're up in Leeds, just give us a shout out. We'll sit down for a cup of coffee, although I would recommend the smoothies in the office there. So I think that's my time. You've been a wonderful audience. Thanks very much, guys. Cheers.